Welcome to another session of numerical system and quantum mechanics. So, there are 15 electrons and a potential Vxy, where Vxy is equal to half m omega square x square plus y square, the degeneracy of the level containing most energetic electrons. So, 15 electrons are there. Okay, most energetic means with the highest energy, the one with the highest energy. Okay, so 15 electrons are there. So what is the energy of this is a what? This is a 2D isotropic 2D isotropic just a second. This is what? This is a 2D isotropic harmonic oscillator. Okay. So what is the energy for 2D isotropic harmonic oscillator? Enx ny is equal to nx plus ny plus 1 whole into h cut omega. Okay. So I can take nx plus ny as n. No problem. There is no problem. Okay. So, what will we do? We will draw a table now. See, nx, ny. Now, this is the energy. Energy is what? Nx plus ny plus 1 squared omega. This is degeneracy. This is number of electrons. Okay, nx, ny, energy, degeneracy. Nx is what? Nx is 0, ny is 0. So, energy will be h squared omega. Degeneracy is 1. And number of electrons will be how much? 2. In one state, there will be 2 number of electrons. Okay, yeah. So now this is gone. Then 0, 1, 1, 0. See h cut 2 h cut omega, 2 h cut omega. This will be degeneracy is how much? 2, 2. Number of electrons will be 2 states. Sorry, 2 states, so 4 number of electrons. Now 0 to 2 0 1 1. Okay. So here energy is 3 h cut omega, 3 h cut omega, 3 h cut omega, and the degeneracy is 3. Okay. So how many electrons? It's the same state. Okay, it's the same state. So degeneracy is 3, electron number is 6. There is one more state. See how many electrons now? 4, 2, 6, 6 is 12. One more state is there. One more state should be there. What is another state? Another state is your 3 0 0 3 2 1 1 2, isn't it? Energy will be 4 h cut omega, 4 h cut omega, 4 h cut omega, 4 h cut omega. What is the degeneracy? How many times the energy is repeated? 4 times. How many electrons will be? Because 12 electrons we already got, so 3 more electrons. So total electrons 15. Okay, but the thing is, the question is what? The degeneracy of the level, the degeneracy of the, where is it? Yeah, degeneracy of the level containing most energetic electrons. So most energetic electrons is this one, 4 h cut omega, highest number energy. Degeneracy is how much? 4. Okay, so the answer is 4. Okay, that's the answer. Okay, okay. Next question. Question number 31, I think. Consider a hydrogen atom in the state n is equal to 2, L is equal to 1, M is equal to 0. The value of R at which the radial probability density the hydrogen atom reaches is maximum. N is equal to 2, L is equal to 1, m is equal to 0. Value of r at which radial probability density. So what is radial probability density here? Yeah. This is radial wave function given. Radial wave function is r21 r is equal to 1 by 2 root 6 a naught to the power 5 by 2 r e to the power minus r by 2 a naught. Radial probability density will be how much? PR is equal to 4 pi r square r21 r square. So it will be 4 pi r square. This is the r21. Put it here. And by 2 root 6 a naught 5 by 2 r e to the power minus r by 2 a naught square. So if I square it, it will become 4 pi r square 1 by 4 into 6 into 8 to the a naught to the power 5 r square e to the power minus 2r by 2 a naught. Alright. So see 4 4 are cancelled out. What is left? Pi r square r 4 by a naught 5 6 a naught 5 e to the minus r by a naught. So PR is equal to how much? If I write it again, pi r fourth by 6 a naught to the power 5 e to the minus r by a naught. So what is the question? Question is probability density, the radial value of r at which probability density of the hydrogen atom reaches its maximum. So for attaining the maximum value, where is it? Yeah. Attaining the maximum value, we have to take the derivative of this is equal to 0, maximum. So d by dr of pi r fourth by 6 a naught to the power 5 e to the power minus r by a naught is equal to 0. So the constants will come out. So d by dr of r to the power 4 e to the power minus r by a naught is equal to 0. Take all of this to right side. So this one will be 4 r cube e to the power minus r by a naught plus, sorry, r fourth plus r fourth minus 1 by a naught e to the power minus r by a naught is equal to 0. Yeah. So e to the power minus r by a naught will go to right side. 4 r cube plus, sorry, minus r naught by a, sorry, r fourth by a naught is equal to 0. So it will be 4 r cube is equal to r fourth by a naught. So this is r. So r is equal to what? 4 a naught. Okay. So this is the answer. What was the question? Question was maximum value of r dash a naught. So in place of dash you will write 4. Yeah. Okay. Next question. 32. The value of the commutator bracket Lx plus Ly, comma L plus L minus will be equal to how much? Okay, Lx plus Ly, L plus comma L minus will be how much? See, one thing you have to remember: L plus L minus commutator bracket is how much? It's 2h cut Lz. Okay, this one you have to remember. Yeah, 2h cut Lz. So I will put it here. So Lx plus Ly 2h cut Lz. I will take 2h cut out. Lx plus Ly Lz. So I can do this as Lx Lz. This is the whole bracket plus Ly Lz. Okay. So 2h cut Lx Lz is how much? 2y Ly, but xz, that means the opposite order, so minus, plus Ly Lz is 2y, sorry, 2y, sorry, ih cut, sorry, my bad, ih cut Lx and y and z are in the right order, so IH LX. So if I write it, okay, let me do this in the next page, this part again. 2h cut LX plus what is it? LX plus LY LZ. So 2h cut LX LZ commutator bracket plus LY LZ commutator bracket. So 2h cut, this becomes what? IH cut LY, but this is in opposite order minus, plus IH cut LX. Okay, I'll take IH cut out. So it will become minus Ly plus Lx. 2IH cut square. Okay, this should be an answer. Right? This is just bracket, okay? Don't think this is a commutator again. This is bracket. Yeah. So this should be option B. Yeah. Next question. 33. For a particular mass m moving in the potential Vx is equal to half m omega square x square. Small perturbation Hp is equal to lambda x is applied only for positive x. Very important sentence. While I was doing it, I took what I did was I thought Hp is equal to lambda x perturbation. So expectation value of Hp, that is expectation value of x. So I thought this is odd function. I made it zero. So I took the answer zero. But that was wrong because here when it happens, when this becomes zero, when the limit is symmetric, like minus infinity to infinity. But here what is given? Here what is given? Wait, come on. Here it is given only for positive x. So the limit will be only 0 to infinity, isn't it? Because positive x. So let's do it. So, okay, first of all, what is the wave function for harmonic oscillator? That we have to know. Otherwise, how will we solve the integration? So, ground state wave function psi naught x of harmonic oscillator is what? M omega by pi h cut 1 by 4 e to the power minus m omega x square by 2h. Alright, so your first order correction of ground state energy will be how much? 0 to infinity psi star x hp psi x dx. So 0 to infinity m omega by pi h cut 1 by 4 e to the power minus m omega x square by 2h cut into lambda x is your hp m omega by pi h cut 1 by 4 e to the minus m omega x square by 2h cut dx. Now then, so m omega by pi h cut comes out like becomes 1 by 2 because 1 by 4 minus 1 by 2. Lambda also comes out 0 to infinity x e to the power minus m omega x square by h cut dx. Right? So now we have to just integrate. Come on. Right. So what's this coming? Is 0 1 is equal to m omega by pi h squared to the power half lambda 0 to infinity x e to the power minus m omega x square by h squared dx, right? So see the formula for x e to the power x to the power m e to the power minus alpha x to the power n dx is how much? 1 by n gamma m plus 1 by n divided by e to the power, sorry, alpha to the power m plus 1 by m. So here m is how much? M is 1, n is 2, alpha is your m omega by h squared. So m omega by pi h squared half the power half lambda 1 by n 1 by 2 gamma 1 plus 1 by 2 divided by alpha is how much? M omega by h squared 1 plus 1 by 2. So m omega by pi h squared alpha lambda by 2 gamma 1 is 1 by m omega by h squared goes up. Okay. So if I simplify it, if I write it again, this way, lambda by 2 m omega by pi h squared to the power half h squared by m omega. So if you see, I'll just simplify it a bit. Into, isn't it? So this will become, if you calculate it, won't it become like this? So write 2 squared by 2m omega. Okay, did you get it? I just simplified it, took this pi to inside, and this one becomes this. Okay, so this is the answer. This is your perturbation, like first order energy correction. Don't make it 0 because this is there. That doesn't mean this should be 0 because this, when does it happen? When it is a symmetric potential. But here it is given only for positive x. That means only 0 to infinity. This is not, this is asymmetric there. This is not symmetric potential. Okay. What is symmetric? When like 0, this up to infinity, both sides. That is symmetric. Simple terms. Okay. So that was the question. The answer will be, you see, I think option C. Yeah. No. Option C. Yeah. Next question. Question number 33, I think. The waveform spin state wave function of a particle is given by lambda, sorry, chi is equal to 1 is column vector 1 to minus 2i 3i if a beam of n naught such particle is sent through a Stern-Gall apparatus with a magnetic field along z axis, magnetic field along z axis, then the number of undeflected particles will be equal to number of undeflected particles. All right. Yeah. So spin state is expressed in 3D space. Okay. So how is it expressed? Like for example, the spin is 1. So mz values will be what? Minus 1, 0, 1. Isn't it? Since the magnetic field of the Stern-Gall experiment is in which direction? Z direction, Z axis. The particles with mz is equal to 0 will pass undeflected. Okay. These ones. So mz equal to 0, particles with mz is equal to what? 0 will pass undeflected. Okay. Yeah. So for this one it is what? For mz is equal to 0, like the eigenstate will be This ones you have to remember. Okay, for mz is equal to 0, eigenstate 0, 1, 0. Okay. So probability. What is the question? Question is the number of undeflected particles will be quoted. Number of undeflected particles means what? Means we have to calculate first what? Probability of finding particle with spin 0, isn't it? That is mz is equal to 0 because mz 0 is equal to 0 particles are going undeflected. So you have to find the probability. Okay. So probability will be p is equal to 0, 1, 0, 1 minus 1 minus 2i 3i, which is given, square divided by, okay. So if you see, this is 1 into minus 2, that is minus 2i whole square divided by chi and chi, that means, okay, row into column vector. So minus 2i whole square is 4 divided by 1 minus 2i 3i. If we do this, 1 minus 4 minus 9. It's 14. Okay, so this will be a 14. So if this one will be, if this is your this one will be like this, isn't it? Right? Because opposite. I have written like this now. This one is actually given. So like Kate is given. So Bra will be what? Isn't it? Complex conjugate. So 1 plus 2i minus 2. That's why it's 14. So 4 by 14. That means 2 by 7. So this is the probability. So number of undeflected particles will be how much? Number of undeflected particles will be, I will simply multiply m naught into p, isn't it? Okay, m naught into p. Okay, so m naught into 2 by 7. All right, is it okay? So 2 m naught by 7. 35. Particle is described by wave function psi r phi is equal to a e to the power minus r square by 2 delta square r by delta cos phi plus sin phi. Alright. So if LZ is measured, if LZ is measured, then what? Then the probability of finding minus h cut. Okay. This one. So you have to first do this a bit. I can write it as f of r, isn't it? I'll just for simplification f of r. This is r by delta cos phi. Can I write like this? E to the power I phi plus e to the minus I phi divided by 2 plus sin phi. I can write like this: e to the power I phi minus e to the minus I phi by 2i. Alright. So I will take the 2 out. So fr by 2 r by delta. Okay, I will do one thing here. Okay, r by delta e to the power I phi plus e to the minus I phi plus 1 by I e to the power I phi minus e to the minus I phi. Okay, now what will I do? See, I will take e to the I phi as common. So fr by 2 e to the power I phi, if I take common, r by delta plus 1 by I plus e to the power minus I phi common, r by delta minus 1 by I. Did you get it? How I did it? See, e to the power I phi to common. So for that, r by delta plus But 1 by I. Again, e to the minus I phi comes r by delta minus 1 by I. Isn't what I have done here? Okay, correct? Alright. So, see what will I write here now? E to the power I phi into fr by 2 r by delta plus 1 by I plus e to the minus I phi fr by 2 r by delta minus 1 by I. Alright. So, I can write it as C1, this one as C2. So this one becomes C1 e to the power I phi plus C2 e to the power minus I phi. Okay, because like your state can be expressed as a superposition of ml plus 1, ml minus 1, isn't it? With equal probability. So probability of, so see, they have this like equal probability. So probability of finding e to the minus I phi will be what? If both of them have equal probability. So P1, P2 is 1. So P plus P is 1 because probability is same. So P is what? 0.5. So the probability of getting minus h cut is what? 0.5. Okay, yeah, that's the answer. Right, that's the answer. Next question. Question number 36. Consider a particle scattering of particles. A mass m, energy E from the equipotential. Okay. VR is equal to G e to the minus mu r by r. Limiting is mu naught, mu tends to 0. This is the differential scattering cross section you have to find. The thing is, this is from which chapter? This is from scattering. This is from scattering. So we know for a spherically symmetric potential, right? For a spherically symmetric potential, scattering cross section is what? Scattering cross section is d sigma by d omega is equal to how much? F theta phi square, that is 4 mu square divided by h 4 square q square, and 0 to infinity r vr sine qr dr whole square, isn't it? F theta phi whole square. So q is equal to how much actually? 2k sine theta by 2. Okay. Now how much is given v? Vr is given g by r e to the power minus mu r. So d sigma by dr will become 4 m square g square by h fourth q square. I took the commons like the constants out. 0 to infinity e to the power minus mu r sine q r dr. Okay, easy things, nothing to like worry. This is mu g square by h fourth by q square, and this one will become what? The integration of this is q square by, okay, got it. So if I do more calculation, it will become what? Q square will cancel out, and in place of this q, I will put what? 2k sine theta by 2. So this one will become 4 mu square g square divided by h fourth 4k square sine square theta by 2 plus mu square. Right? Now what? Now what? Mu is 0. Mu tends to 0. Theta is how much? Pi by 2. Okay, so just put it there. And we know k square is how much? 2me square by h cut square. Sorry, 2 me. 2 me by h cut square. Just put everything. So 4 mu square g square. Okay. Okay, this one was actually your my bad. This is on you. Okay. So this becomes 16h4. Okay. And into 4m square e square by what? Fourth by 2. So the answer becomes z square by 4 e square. Okay. You try it from here. Try to do yourself. I have skipped some steps. Right. Up to this point I told you. So you try from here. Right. Okay. So these are some of the questions that we did in this session. Okay. So there'll be more sessions ahead. So keep tuned with me. Okay. Yeah. That's it for today. Thank you.